Lesson 3.6, vertical transformation. After this lesson, you'll be able to describe the vertical transformation from a parent function, describe the vertical transformation between two linear equations, and given a graph, translate the graph vertically and write the equation of the new line. Let's get some vocab first. So we got a couple of things here for vocabulary. First up, what a transformation is. A transformation is simply the changing of a function. Then we have the parent function for linear. This is the most basic form of a linear function, and it looks like this. Also, just remember, we could have a y. That's a big Y. Holy moly. Hold up. There we go. We can have a y instead of that f of x. Just remember that. Then we also have the general form for linears. And this is the way we represent a function. Let me highlight that for you. And then, of course, that looks like this. What we're going to be paying attention to is the k value. Okay? And then what does the a and the k value mean? Well, that simply is a is the steepness, k is the vertical movement. And we're looking at vertical transformations, so we're looking particularly today at that k value. Are we going to move the graph up or down, and then what does that look like? Let's first identify the a and the k value. So here we go. First off, they say if f of x equals x, list the k and the a value for the following functions. So what helps to actually know what the k value is going to be is to first look at what the k value actually is in the parent function. So if I look at my parent function, my a value here is the coefficient in front of the x, which if it's not there, it is a 1. And then I have nothing being added here, so then my k value actually for my parent function is, you guessed it, 0. So we're looking at moving from 0 to our new k values. So let's look at our first function here. A, g of x equals 3x minus 2. Well, again, if I want to, I could write that general form right above it, and I can identify, well, what's my a value and what's my k value. Again, remember, we're moving from 0. So I got to think about from 0 to negative 2, that means I'm going down 2 for my a value. My k value. Ugh, let's work on that better. My a value, we can see lines up, is actually just a 3. Let's see another one. So over here again, my a value would be in front of my coefficient, which is a negative 2. And then my k value, well, again, we're going from 0, and we're trying to get to positive 2. Well, that just means we're going to go up 2, so that's a positive 2. Go ahead and try out C and D. Pause this video and then try them out. So the correct answers for C is our k value is a positive 6, and that's because we're going from, again, 0 to 6, which means we go up 6, so it's up positive 6. Our a value is just the coefficient in front of x, which is 2, our steepness, or slope. For D, g of x equals 1/3 x minus 8, we're going again from 0 to negative 8 this time, which means we got to go down 8, which means it's a negative 8 for our k. And then, of course, the slope or the steepness is just the coefficient in front of x, which is 1/3. If we had to identify which of these had the steepest slope, like we've talked about yesterday, we look at the absolute value of each of those steepness values, and we can see, oh, yep, winner, winner, chicken dinner, A is the steepest. Just remembering things from yesterday. Yeah. Let's continue on. So here, example 2. Given f of x equals 2x plus 3, g of x is f of x shifted up 4. So they want to first know what is the k value, and then after that, the equation for g of x. So first off, let's get the k value. Well, first off, our k value is the vertical transformation, and they're telling that we're shifting up 4. So that is actually our k value. So what is a k value? Well, k is equal to a positive 4. Now, to write the equation for g of x, we got to take f of x, which is 2x plus 3, and we got to shift it up 4 on the k value. which here is currently this value. We got to go 4 up from 3. So we could just add 4 to it. So what is 4 plus 3? 7. So now we can write our new function for g of x, which will equal 2x plus 7. We have our equation. We have our k value. Let's try another one. Example 3. Given f of x is equal to negative x minus 15, g of x is f of x shifted down 7. What is the k value, and what's the equation for g of x? So again, we got to find the k value and the equation for g of x. Remember, the k value is just your vertical transformation, which here is we're going to shift down 7. So then what's our k value? Well, if I go down, that means I'm at negative 7 because I'm going down. How to get the equation for g of x? Well, again, take the equation for f of x. If I can actually write it here. Here we go. It's equal to negative x minus 15. We have to go down 7 from a negative 15. So then I'm going to just subtract 7 from a negative 15. Go ahead and do that math. We're going to have our new function, which will be g of x, is equal to negative x, and then negative 15 minus 7 is negative 22. So here is the equation for g of x and our k value of negative 7. Now it's your time to shine. Go ahead and try out example 4. And you heard that beep? That means it's your time. Pause the video, please. Here's the correct answers for example 4. Our k value was negative 14 because we're going down 14. And to get the equation for g of x, we again took f of x, which was equal to 18x. We didn't have a k value for f of x, so since it's not there, it's 0. So we added the 0 here. And then since we're going down 14, that's minus 14 from 0, which ends up being negative 14. So our equation for g of x equals 18x minus 14. Example 5. Here now they want us to graph f of x and g of x, then find out how did f of x change compared to g of x, and then, well, if g of x equals f of x plus k, what is the k value? And that's what it wants to do. So let's first off do the first step here, and let's actually graph both f of x and g of x. So let's go ahead and graph that. I'll graph f of x in green. So again, if it helps, you can put the slope-intercept form right above it, and if it lines up, then you're good to go. Our y-intercept is 1. So I'm going to go to 1 on my y-axis. My slope will be 2 over 1. So up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then I can draw my line, making sure it's nice and straight as possible. And, of course, with arrows. Bam, there we go. Now let's get our other function. We'll graph that one in blue. So g of x, so y equals mx plus b. We can see that for g of x, our y-intercept is positive 5. 1, 2, 3, 4, 5 right here. The slope here is also 2 over 1, not 2 over 2. What the OMG? 2 over 1, there we go. So that's up 2 over 1, up 2 over 1, and then, of course, graph that guy. Again, making sure you have arrows on a line and that is as straight as possible. And there we go. So these are actually called parallel lines because they have the same slope but different y-intercepts, which we'll get to a little bit later. But they're parallel lines, which means they're never going to intersect, which is also good to know. And so now we're looking at, well, how did f of x change compared to g of x? So we're going from f of x, how did f of x change to get to g of x? So, of course, we probably should have labeled our graphs. Our green is f of x. Our blue is g of x. And we're looking at, well, how did f of x change compared to g of x? So we got to look. So if I go from f of x y-intercept, which is a positive 1, and I just count up to get the g of x, 1, 2, 3, 4, well, we went how far up? 4. So how did f of x change compared to g of x? Well, it shifted up 4. Choo-choo! Now, they want us to, well, if g of x equals f of x plus k, what is the k value? Well, we actually already found the k value when we found the shift movement. Because remember, the k value is just your vertical transformation, which here was up 4. So what's my k value? That's a positive 4. Use this example to work example 6. So now it's your time to shine again. Try out example 6. Pause the video to see if you can do it. I know you can. Pause the video. Pause it. Pause it. Here's the correct work for example 6. So we first graphed f of x, which I graphed supposedly in green, but it turned out black. My bad. Then I graphed g of x in blue. We're looking at how f of x changed compared to g of x. So I'm looking at, well, how did f of x get to g of x, which here we went up 3 from our y-intercepts, because that's what we're going to use to find out that vertical transformation. So then we shifted up 3. And then the k value, of course, is that vertical transformation, which if we go up 3, makes it a positive 3. Let's see another example. This one's a little bit different. This one, they give us a graph already done. So first off, f of x equals x plus 3 is graph below. So what helps is let's actually call this f of x right now. They want us to, and this is what we have to do first, graph a new function so that f of x is shifted up 2 and label that g of x. So how we do this is we just look at our vertical transformation. We got to go up 2 from the y-intercept of a positive 3 on f of x. So I go to my y-intercept here, and I'm going to go up 2. So 1, 2. This is where I'm going to put my new y-intercept, and then I graph my new line, keeping the slope the same. The slope in f of x was 1 versus 1. So I got to go up 1, right 1, up 1, right 1, up 1, right 1. Then, of course, graph that line, which we're going to call this, again, g of x. And we got to make sure we actually label it as g of x. So there's my line. And then, of course, they want us to label it g of x. This is a really good test question. Wink, wink, nudge, nudge, say no more, say no more. So now that we have graphed a new function, we shifted it up 2 and labeled it g of x. They want us to find, well, what is the k value for g of x? Or not g of x, but what's the k value that we added to f of x to get the g of x? Well, again, the k value is always just that vertical transformation. So we shifted up 2. So what's our k value? Positive 2. Now we need to write the equation for this line. In order to do that, and I'm going to move this up so I have a little more room so we can still see our graph and also our original function for f of x. We're going to do it just like we did before. We're going to take the original function, f of x equals x plus 3, and then we need to combine our k value with this, which it was a positive 2. So I'm going to add 2 to that very end piece, which is my y-intercept, and then we write our new function for g of x. G of x equals x plus 5. So our k value was 2. We moved that 2 up from that positive 3, got it to be 5, and therefore we have our equation for our line, x plus 5. Now it's your time to shine again, so it's your time to try the next problem out on your own. So here's example 8. Again, the graph is already graphed below for f of x, so I would make sure you label it first. And then, of course, go ahead and do what it's asked. Graph the new function that's shifted up 5, label it g of x, find the k value, and write the equation for a line of g of x. Pause this video, please. Here's the correct work for example 8. So again, we need to graph a new function that was shifted up 5 and label it g of x. So again, I went to my y-intercept on my f of x, and I just moved that point up 5. 1, 2, 3, 4, 5. Put a new point there, and then again, use the slope from the original function f of x, because that does not change. We're just moving the line up or down. And so it was 1 over 1. So I went up 1, right 1, up 1, right 1, up 1, right 1, and drew that line. And then I totally forgot, and let me do that now. Glad I caught it. I forgot to label it g of x. Make sure you do that, because that is for points. Then we found the k value. Well, the k value was just that vertical transformation. So since we went up 5, it's positive 5. And then we use that k value to add to our original function and got our new function for g of x, x plus 4. Now it's your time to continue to shine. Go ahead and start the perfect practice problems on the Google Slides. When your teacher tells you to take the quiz at that time.